Hello, everyone. Thank you for having me. So I'm a PhD candidate at the University of Oxford on the topic of sleep and circadian rhythms in dementia. So I'm going to talk a little bit today about dementia and then a bit about work that we've been doing with WCS, who are speaking after me as well, about characterizing the light environment before and after implementation of circadian lighting. So firstly, this has already been covered a little bit, but the sleep-wake cycle is controlled by two main processes. So this is the homeostatic sleep drive and then circadian rhythms, which we've talked about quite a lot. So the homeostatic sleep drive is essentially an increased pressure to go to sleep the longer that you've been awake. When you sleep, that decreases and then continues. And then, of course, circadian rhythm that we've looked at, which is essentially your internal alignment to the sleep-wake cycle. And circadian rhythms are part of the non-image forming function of the eye and are primarily driven by the intrinsically photosensitive retinal ganglion cells that express melanopsin. And these are most sensitive to light at 480 nanometers. But that's not to say they're not sensitive to light at other nanometers as well. And what we know is that light can have a direct effect on numerous different aspects of physiology and behavior. And so sleep and circadian rhythms are one example of those. Also things like your hormones, your mood, pupil responses, etc. So if we think first a little bit about dementia. So dementia was first described over 100 years ago now by Alzheimer. And one of his first patients, Augusta, had quite significant circadian disruption in terms of being awake the whole night and then sleeping throughout the day. So this sort of misalignment has been known about since we started thinking about dementia. And dementia is characterized by a quite long progression. So often the things that happen before people have symptoms occur in the brain maybe 10, 20 years before the symptoms ever take place. And it's also associated with degeneration of the brain. And alongside that, you have quite significant worsening sleep and circadian disruption across that disease trajectory. So what do we know so far about this sleep and circadian disruption in dementia? So we know that as people get worse, they're waking up more, they're taking longer to fall asleep. Sleep duration may be increased or decreased, often depending on how you're actually defining sleep. And if we think about sleep stages measured from polysomnography, so here on the left hand, this is recording from polysomnography, which is sensors, electrodes on the head to measure your brain activity, and you get these sleep stages from it. So people with dementia tend to have a shift towards what we say are lighter stages of sleep, so more this N1, and a shift away from stages of sleep like N3 or deep sleep and REM sleep as well. And this culminates in a worse sleep efficiency. But there's a lot that we really don't know. So in terms of things like sleep microstructure, so patterns of activity in the brain that are really important for memory consolidation. If there's changes in things like people's circadian rhythms, and if that's driven by a change in their light exposure, and whether that is internal biological change that's happening, or is it driven by a social change in terms of, are you diagnosed with dementia and then you don't really want to go outside as much because there's so much risk in terms of getting lost. We also don't know too much about how this relates to people's cognitive functioning or their biomarkers for dementia, things like amyloid and tau proteins, and then how this changes within a home-based environment. So it's not very common for people to measure people's brain activity whilst they're asleep in the home. And that's what I am aiming to do with my ongoing PhD study. That's comparing people with mild cognitive impairments, very early stages of dementia, to healthy older adults, using polysomnography, actigraphy, looking at light exposure, their cognition, and dementia biomarkers in their blood. Thank you.